Well, welcome to February's Perl Mongers group. Today we're going to take a look at Kafka, and Perl and Kafka actually, and because it's Kafka and the whole Roach thing, I said a story of love and a can of Raid. So basically, Jay Krebs, he started out writing Kafka in LinkedIn, and basically I want to start with the name. And he wrote in a blog post, I thought that since Kafka was a system optimized for writing, using a writer's name would make sense. I'd taken a lot of lit classes in college and liked Franz Kafka, plus the name sounded cool for an open source project. It kind of does. So that's what it's named. So what is Kafka? Well, it is a distributed streaming platform. And if you were like me, you would say, well, what in the world does that actually mean? And we'll get there. So as I said, it started at LinkedIn. About 2011, 2012, it became an actual Apache project. And it's primarily written in Scala and Java. And basically, it's designed to be fast, scalable, durable, and reliable. Like any good, great sales pitch for a distributed streaming platform. So before we really talk about Kafka, I want to step back again. Jay Krebs wrote in 2013, he says, one of the most useful things I learned in all of his 6 years at LinkedIn was that many of the things that we were building had a very simple concept at its heart, the log. So basically, let's take a look, a log versus what Kafka is. So a log, an error log, the things that you find in usually var logs, it's append-only, single file. It's ordered by time, you write to the bottom of it. And any message is accepted. Whatever you want to log, the log will write to it. So what does Kafka do? Well, Kafka appends only to one topic or partition. It orders those messages by time, and it really doesn't care what you're sending it. It'll accept any message. So you could see, at the core of Kafka is just the idea of it's a log. Well, it's actually really like a big tail minus f, if you think about it. So you have your log file, and your application is writing it to it, and you're trying to figure out what's wrong with it, so you just tail F it, and it just streams by and streams by. And I'm pretty sure I just screwed up my slides on this. No, okay, anyway. So this is kind of how Kafka goes. It treats every topic like a log. If you have a topic, that's a grouping of messages ordered by time, and it allows you to see those through that order. Again, it doesn't care what you've read. It just holds the message. It's up to you to tell it where you are in reading it. It is the reader's responsibility of where their location is. And we're going to get into more specifics on that later too. And basically, Kafka's purpose is to simply store the messages for a set amount of time, like your log file. If you have a log rotate going, basically, you get 1 day, it rotates, and after 7 days normally, it falls off. If Kafka doesn't have it anymore, it's not there. If you didn't read it in time, well, it's gone. So, that's great. You have a really fancy log now. So why am I using Kafka? Well, basically, it helps you tail F from anywhere to anywhere. Tailing a log is great when you have the one box. When you have a production cluster that has 96 boxes and something goes wrong with it, you don't want to log into 96 boxes to find out. And even worse is, well, it started at this box, and then it went to this box, and then it went to that box. Now I have 10 different logs, and I don't know what the order is anymore. Well, there is a timestamp, so that's kind of cool. So now I can kind of paste things. Kafka takes care of all that for you. So basically, Kafka, with this in mind, to give you the better log, it's basically built for speed, for high throughput, for writing and reading. This is basically both on consumer end and the producer's end. It's scalable, and this is done through basically, if you need more resources, you can add them without downtime. The Kafka cluster will take care of that for you. Very durable. It basically uses the distributed commit log, which I'm not exactly sure what that is. It just means that it writes your messages to disk very fast. So if you give it a message and the power fails, the likelihood that it's actually on the disk is very good. And reliable. It basically uses redundancy. It makes backups of its partitions so that if a disk corrupts, if a server falls over, it's not like, oops, I just don't have that log anymore. It's like, oh, it's over here now. So again, the reason to use Kafka is that it takes all of that away from you. It basically gives that to you for free. You don't have to worry about how you're going to get your information to your users because Kafka does that for you. It is your log. It is your interface to the outside world. So talking about some terminology here, basically Kafka has just some basic ideas that you need to keep a hold of. First, you have the topic, which again is like your log file, but in this case it's a stream of related messages. You usually have one log per server. So you have one topic per idea. So basically, yeah, if you need to see what's going on with it, you only have that one topic to look at. Partitions are basically sections that topic messages go into. So into a topic, you send your messages in, and you can have many partitions. So if you start getting a lot of messages coming in, they can go into different partitions. And in that way, that's basically how it gets its scalability. It allows to take in as many as you need as long as you keep having the right number of partitions. If you have one partition and you're trying to put in a terabyte of messages, you're going to fall over. But if you configure it properly, it will be able to handle that. The partition offset, this is basically where in that partition, where in that part of the log are you. So that's your offset. Brokers, these are what actually stores the partitions. These are your hard drives. These are the guys that they take the information and they make sure it's in the right place and that it's redundant and it keeps it going. And the Kafka cluster, all it is more than one of these brokers. So for a truly redundant cluster, you want to have a couple of those. And then you have your producers and your consumers. It's basically the program that writes to the cluster, your server, your service, your whatever, and then you have consumers. They will subscribe to a topic and ingest that. And you don't need to know how any of this really works. You just, if you're lucky, you have a sysadmin who set this up correctly. He or she tells you where the topic is, and you just write to it, and then someone else reads from it. You don't care if one person is reading your data or if a million people are reading your data, because Kafka and the Kafka admin, hopefully that's not you, will be able to take care of that. That is their purpose. That is its purpose, is you can write your application. You don't have to worry about getting your information out of the application. So, but I just said that, Kafka doesn't care about where you are in the log. That doesn't really help much if I have to keep telling Kafka what's going on. And that's where we get Apache's Zookeeper. The Zookeeper is the organizer of the whole thing. Apache's brokers are stateless. All they know is that they can store information. They are given a message, they store it. And they store it in an efficient manner. They don't care where you've read in it. They don't care what it has sent out. They just know that they have data. They don't even know where the rest of the data is. The Zookeeper manages all of that. It coordinates the brokers. It makes sure that if you set up a system that has 3 brokers and you have a system and you write to your topic on it, your producer, it will send the data to the topics or the partitions on each broker equally. If one of them goes down, that's fine. It rebalances. Now you're going to 2. You're getting overwhelmed, you add in another broker, and it announces itself, and then it knows, oh, now I can start writing to you here, and it rebalances itself again. This is what you get for Kafka. That's the reason for using it, is it gets your data out, it takes your data in, and you just don't have to care. So this is your ecosystem of a cluster. And this is a little bit further than what this talk is going to go for and what the demo is going to show. But this is basically what we were seeing. We have our Kafka clusters, which is made up of several brokers. We have our Zookeeper, which is keeping them all in check. You have producers that push messages to the brokers. If we add a broker, it will announce itself to the producers, and then they will know, oh, I can start pushing information down into this broker 4 if it needs. On the other side, you have consumer groups, which is basically the reader. You have one program, but you have many instances of it. By putting it part of this group, it helps you facilitate the reading from each of these brokers, each of the partitions in the brokers, so that you get the whole message that you're looking for. Again, the Zookeeper keeps track of where in each of those partitions each consumer is, where they are reading for. The consumer works with the Zookeeper to keep that information updated so that everyone kind of is happy this way. This is the whole cluster. And by using consumer groups, you do get a lot of this nice handling that we're not going to see in my introductory example here, because, that's a more advanced topic. I just wanted to show you here how basically you can interact with a Kafka cluster and how easy it is using Perl. But I just want you to know that even though my example is limited, this is where we're heading to. We're heading to this big, wonderful ecosystem where you can push as much information as you need, and you can write as many consumers as you want to do as many different things as you need, each one of them reading out of their segments, of their topics. So you can have a consumer group who is basically doing monitoring for bad behavior. You can have a consumer group who's doing analytics. How much have you sold? And Kafka, with the Zookeeper and its ecosystem, tries to make that much easier for you. So let's take a look at some Perl, which you're actually here for. So fortunately, I didn't have to really write that much. On Sipan, there's a Kafka module, and in it has a whole, I should probably just show that to you guys. I'm glad nothing bad came up. So basically, on Sipan, you have the whole kit and caboodle. It's an interface, gives you a connector, producer. Oops. How do I make the font bigger on this?
It should be Command plus. Command Shift plus.
It's plus, not up arrow. Sorry. So yeah, you have the connector, producer. Actually, it gives you the whole, a lot of good examples too. There we go. So you have a connector, the producer, consumer, objects for your messages, basically functions for getting the protocol together, and a lot of lower level. This will be in our next talk that hopefully I can convince someone who has a lot of Kafka knowledge to do. So there we go, to consult. So the idea again of Kafka is a stream. So before, what we've always been used to is, what's the temperature outside? Let me go look at the thermostat. Let me go look at weather.com. Let me go and inquire. And I just don't want to know what the temperature is right now. I'd like to know what it was, 5 minutes ago and 10 minutes before that, and so forth and so forth. And so then in the computer world, we started batching things. It's like, well, I want to know all this information. It's like, let's pretend that I came and asked every 5 minutes. And then we batch it together, and then we process it that way. This is all, I come to you, the producer, the place with the knowledge. I come to you, O thermostat, and I ask you, what is the temperature? And in being lazy, I write a little thing that asks for me 5 times, then I come to it, and I say, give me your summary. Well, Kafka, it does it the other way. It says, it's the whole streaming idea. The thermostat is just going to tell me every 5 minutes, here's the temperature. And my consumer is going to take that in and do what I need with it. So, because I didn't want to have a program that we're going to just sit around here waiting for the temperature to change for a couple of hours, I stole the data from openweathermaps.org. They have some sample data. And I'm ingesting it, and I'm making it look like we are asking, yeah, there we are. We're asking in 5-minute increments, and then I will be, the time delay is 2 seconds. So every 2 seconds, we're going to pretend like 5 minutes has passed, and it's going to say, hey, the temperature now is this. So basically, I mean, all of the other code is just me getting my math right. And if you look closely enough, I'm sure someone will figure it out that I didn't get it right. But anyway, so to get a producer, we make a connection. And this is all, by the way, in the Git repo. It was in the email. It'll also be on the final slide, so you can download this and play with yourself. It uses Docker and Docker Compose. And the beautiful beauty of that is it takes care of the network for you, so that from this container, which is my app container, it will know that Kafka is the container that is running my actual Kafka broker. So connect to my broker. I'm not giving a port because I'm just using the default port. And I'm giving that connection into the new for the Kafka producer. So this is my producer object. And then I do all my math, I get all my data. Basically, I'm asking the thermostat, what's the temperature? I'm making it a message, and then I'm going to write out to the screen that I'm doing something so that we can see that it's actually happening. And then I send it off to the producer. That's pretty much it. I give it the topic. The topic I gave it was weather. Made sense. I give it a partition. Again, this is not the nicer example of what we're working towards, which is going to be the working group, which basically will take care of the partition for you. Here I actually have to do it. It's basically I've created a Kafka cluster of one broker with one partition with one topic. It's just a good way to start. But so in this instance, I actually have to tell it the partition it's going into. Your producers will, when they get into the group, they will figure this out on their own, or it will be done for you, because it will have talked to the Kafka brokers and said, how many do you have? Oh, okay, this message goes here, this message goes here. Right now it only has the one destination. We give it the message, and I hate ordered variables, but I want to give it the time too, because if you don't give it this, then everything goes in at timestamp of -1. And that just is not helpful. Although, nice enough, they do go in order. So when you read from it, it's all in order. You just don't know what time it is. The key is basically, think of Kafka as kind of a key value mapping or cache. This helps you tell it which partition to go into. So this is for reading speed, I believe, primarily. So if you have everything that belongs to a session or a city, you want that all to go into the same partition. So when you read from it, you don't have to say, okay, I get message 1 here, message 2 there. No, we're all forced into the same partition, and they're all in there in order. So basically, it can just spew them out really fast for you. Obviously, with one partition on one broker, with one topic, this is not really needed. So you can hard code this value. You can use an algorithm to uniquely identify it so that it actually gets distributed. You want to be very careful, especially if you're dealing in higher volumes, because if you do the key improperly, then you're writing all your messages into one partition while you may have 5 of them just sitting there with nothing in them. And obviously, then you lose then you lose everything. And then, I go down, I sleep my 2 seconds because we don't want it running away too much. And then I go and ask my thermostat again. So really, that's it. This is how I get my messages to my to Kafka from my producer. So basically, I have the weather, I'm going to run weather producer. It tells us, well, don't mind the very top. The data is from last year. And, last year in I didn't output the time. But starting around noon on January, February, March, basically it was 66 with skies clear.
So at this point, you're only writing into a Kafka broker?
Yes, I am producing, and it is sending stuff to Kafka. Nothing is consuming it. Oh, yeah, nothing is consuming it. Do not pay attention to the other process that's running right there. I forgot that I left that running. So nothing is consuming it. And nothing is lost, per se, in this instance. Kafka will hold on to it. It will hold on to it for a certain amount of time before it lets it fall off the end. So let's go take a look at my consumer, which you did not see running. Is that a good size? Okay. So same thing again. Okay, here I actually did kind of nicer coding, I actually put it in a try and catch because I really wanted to write this in a way that you all could run a consumer on your laptops and hit my broker here and see what my producer was showing. And it wasn't having any of that. I couldn't get the network settings right. So, but in doing so, the nice try and catch gave me, much better error handling for the Kafka has its own exception class, which gives you really nice code and a really good message. When I set this up, it was like, oh, that's my problem. And I was able to not fix it, but I knew exactly what the problem was. So again, we create our connection to the host Kafka. Again, notice there's no Zookeeper in this. That is all happening behind the scenes. I go talk to the host Kafka, and it goes and talks to Zookeeper to figure out, well, what's the state? Where should this go? Where is this anyway? Even though it all really is just in the one topic, in the one area, in the one partition. So, but even in the full version of it, you really would just hitting Kafka. So it really looks like Kafka's doing everything, but it's hiding all the complexity for you. We create a consumer object, off of the Kafka consumer. And at first I just did next offset 0, because it started from 0. I set this box up fresh. It should start with 0. And then I started getting errors saying, no, that's outside the boundaries. And then I found, oh, yeah, let's get the earliest offset for my topic and my partition. So this is how a consumer can regulate itself. If this is the first time, it's going to get the earliest. If it's been running and already knows its offset, it will have to store that itself. Again, once you get to consumer groups, that starts doing it all. You get that for free at that point in time. Here, since we're doing it by hand, we have to know. So we ask, well, I want to see everything that's been happening already, that's already been produced. So give me the earliest offset, and then just run until something kills you. Who cares? And basically you fetch. You fetch from your topic, your partition, starting at that offset. You can also give it a size. If this is not going to be a problem because basically we just have weather data. It's a temperature and a small string, nothing much. But if you're getting large chunks of data, if this Kafka is storing books for some reason, and each message is an entire book, and it's the Library of Congress, you don't want to leave that off, because you will crush your machine probably. And it returns, an array of messages. These are Kafka. These are of type Kafka message, which is a really nice interface. Basically say, are you a valid message? If not, tell us why. And then, what is the current weather is, and show me your payload. This is what the producer has been sending out. This is debugging information. It's publishing 82:59, skies clear. Eventually it gets dark and stormy. It's kind of fun if you want to wait the whole 30, 40 minutes. And of course, we need to get the next offset. They seem to be, numerically sequential, but I wouldn't guarantee on that, because if you screw this part up, then get a out of bounds error, and then you're all done. So, and then you just wait and you ask again. And the nice thing about this is if there's nothing there, so this is really wasteful of CPU cycles. So basically, we get everything, and we know that the producer is only producing every 2 seconds, because we wrote it. So it goes down here, it says, give me everything from the next offset. Well, there's nothing, it returns undefined. So then it does it again. So it's just constantly asking Kafka over and over and over again. It's like as fast as it can, it's asking. And then the second that something is in there, it will immediately spew it out. And Kafka is just fine with that. I did not see any, again, one-to-one, so what performance would I actually see? But obviously you want to write this loop in a smarter way. But this works too. You can just say, beat the living crap out of that machine until you get your message. And so there's the producer on the right. We're going to hide most of it. And then here. So obviously, since I've already been running it, and I'm asking for the earliest offset, you're going to see everything that it's already produced. And since I've already run this a couple of times, there's going to be a lot of stuff here. So, oh, that's it. Sorry. And there we go. Now you can see producing, receiving, almost instantaneously. And that's what Kafka gives you right there. I've written an application that bugs the thermostat for the temperature, and then, well, I wrote an application that gets that information out of Kafka, and all they do is print to the screen, so it's a really useful program. But the idea is that the consumer here can do something. I want to know the average temperature. I want to know when the temperature actually, well, changed is bad. I want to know when the sky is no longer clear, and it can emit a message somewhere else. But I wrote both of those programs in isolation of how they're going to talk to each other. The only thing they needed was Kafka, and Kafka takes care of all of that. And the claims are that no matter what the throughput, even to like terabytes of data, Kafka can handle it if you give it the machines underneath and the disk space to handle it. So that's basically how you integrate Perl with Kafka, by just using those two libraries.
Wait, so is there a way like to subscribe to the event so that like you're not doing the looping?
Well, you have to loop. So right, and to pull the loop.
Subscribe.
Oh, so there's
But-
no way to subscribe you
Yes,
install?
yes, there is.
There is?
There are ways to subscribe. And
Is there?
It's a polling.
But I mean, it's still, a stream is simply something asking for information over and over again. You don't want it actually making like a socket connection, because then the host machine is going to run out of sockets. So it's basically, yes, all you're doing is asking over and over and over again, but you aren't asking, you're having this ask for you. And I'm sure that there's probably a smarter way of writing this part where it may actually just wait until it gets something, so I'm not burning CPUs here. I haven't gotten to that part yet.
So one way you can scale this, and yes, it's a polling, you're subscribing to polling, right? Because you have one thread per partition. So a way to scale this is increase the number of partitions per topic. So if you had a topic with 16 partitions, you could have 16 threads polling simultaneously, each thread handling one partition's worth of data of that topic. And as you was talking about earlier, being able to have a key, having your data keyed, he had undef for his key. But one really cool advantage is if you have a key, you can do things like collapse your data so that it only has one record per key. So if you're going to have a producer produce into a topic, it could produce a new message that's the same key, basically a new version of that message, and then it would tombstone the old one, and the old one would get, sorry, yeah, that's a good call. But the idea being that you could scale by partitioning out, and then your threads are going to be able to each handle that as fast as they possibly can.
So yeah, what I showed is the basic example. It's just the easiest way of, sorry, John, of what we're building towards. It's when you start having these consumer groups and you have multiple partitions, that's when it looks more like streaming, because that's when what you're saying, you're able to distribute all of the storing and the reading and writing, and then consume it much faster than you would. Basically, if consumer one talked to producer one directly, they will be only able to communicate at that one-to-one. By putting this in the middle, all of the producers can disseminate the information in such a way that the consumers can access them immediately and quickly. If that makes sense. At least that's what I hope we're building towards next time, which I guess I just signed myself up for next time. That's pretty much the end of the talk. These are the resources that I used. I will be updating the GitLab repo with these resources in the README, and I'll be should have been emailed to you, so you should have access to it, so you don't need to write all this down. Some really great information. Obviously, this is the repos across the top, but these are the two. I just lost his blog post from like 2013 from the guy who wrote it. Forgot his name. Of course, kafka.apache.org, a lot of great information there. And the Kafka, the Definitive Guide, that O'Reilly book just came out. If you want a deep dive, that's your deep dive.
One more book I can recommend.
Okay, one more book? Oh, iHeart, yes. Great.
That's by Jay Krebs.
Oh, yes, Jay Krebs. Okay, that makes so much sense. Jay Krebs, the guy who wrote these guys, he wrote iHeart Log, which is a really great dive into logs. And it's actually a shorter read. I believe it was basically, it came somewhat out of this thing, logs, what every software engineer should know about real-time data's unifying. Yeah, it's really good book on logging, and it does actually make you understand where he's coming from in the sense of that everything, databases, Hadoop clusters, everything, it's just a log, and we just doing it in a much more efficient manner. All right? Yeah.
Let's say you've got multiple consumers with the same topic, and they're remote. Does Kafka smart enough to use IGMP and IP multicast to get the packets there efficiently?
I don't know. Basically, you're talking about more network topology, and
Yeah,
right.
I was
On,
wondering, is it smart enough to set up multicast to deliver the same data to multiple clients? Like Netflix.
well,
if I-
no, that,
You would connect via TCP.
but it
Not really?
no.
No. You wouldn't want to risk
Well.
messages dropping on the floor. You want to know that you're going to get every message that you ask for.
So you're not going to use this for video streaming?
No.
No, this is for logging, analytics, and the analytics are usually, the examples I've seen are done elsewhere. But
You
yeah,
get high data integrity with Kafka.
yeah. And as far as the consumers go, especially if you're working in this consumer group, the Zookeeper via Kafka will keep track of where each consumer was in each partition, and so that if it does drop on the floor, another consumer can come up and continue on right where the other one left off. So that's where part of the redundancy is. Doug?
I just wanted to mention for anybody that already uses Log4Perl, I was just curious, and there is actually a dispatcher for Kafka.
Oh, nice. Okay,
Using Log4Perl.
nice. So Log4Perl has a dispatcher for Kafka.
And easy to transition if you
Yeah.
got Log4Perl.
Thank you. I didn't even think to check for that, but yeah, that's great. Well, yep.
Can you, I'm gonna throw you a softball.
Oh dear.
Can you touch on why Kafka gives us scalability over a microservices architecture?
Okay, why Kafka gives us scalability over microservices architecture? I wouldn't. I don't know if I would compare those two in that way, because Kafka. So the microservices that they're talking from. Oh, I see what you're saying. In the communication in between microservices, right?
If I had requests
Right.
coming from down from the top from clients to middleware to
Right.
middleware to core services, if I had that core service pushing out messages, how could I increase my performance and scalability to service my clients with Kafka over microservices?
Well, I guess the question being, with the microservices, then each microservice would have to be built to handle the scale at which it needs to work at. Kafka gives you the scalability. If your microservice needs to serve one client, for one day or for a year, and then that's it. That's it can handle that. If all of a sudden it balloons up, Kafka can adjust for that. You don't want to write that flexibility into your microservice, because then you have a really expensive microservice, because you've built, you have a Yugo and you've strapped it with a Porsche engine, but it's never going to go over 5 miles an hour. So Kafka.
Even better, sorry, let me
Okay.
give you a cheat sheet here, and you can repeat it back into the mic, is stream backed caches for an API at each layer.
Oh,
So you write it so that you're pushing out messages from the core out, and each layer keeps its own stream back cache. It's reading from the topic below it, and it's keeping its own cache of a data that
Right.
it's reading from changes that are coming in, and it serves its own API maybe up above it, but it doesn't have to make requests down. So the scalability is increased by being able to handle that.
right. Oh, okay. So in a stack, because you're pushing up
Yeah.
through the layers of the stack,
You're not
you don't have to request back down, because each layer knows it has the most current
One
information.
message up to handle 100 requests out.
Right. And then that will be more of aggregating and
Big
yeah.
challenge with that is it's got to be adopted by enterprise level.
Yes.
You can't just have one piece of your enterprise adopt that and go, this is going to work, because it's not. But if the whole
So-
enterprise adopts it, it's awesome.
Right. And this goes back to the idea of I tried to figure out how to display this in a slide, but I never could. We've been so used to, I'm going to come to ask to you, I'm coming to the thermostat to ask, and that gets laborious, so I'm going to write a batch program that I'm going to ask that batch program. turning that completely around, yeah, I can't do that in a well, in my example, I can do it in a vacuum because I'm the only person. But if I'm working in an entire room of people who want to know what the temperature is, if all of a sudden the thermostat is pushing out, but I'm the only one listening, there's no gain there. Everyone, you need to change your mindset of, I'm going to get the data sent to me rather than me get it when I want it. I need to be ready to receive the data at almost any time. So you have to reverse the way that you look at your architecture. Cool. Thank you. But anyway, he's been working on this for the past like 3 or 4 months. So that's why I was trying to set all this up and say, see, I built this for you. You can now write a better presentation.
I've never written it in Perl, so it's awesome to see the implementation.
And the implementation's fairly easy. And as far as there are, the modules do give you access to the group ID. So then you can start actually doing the consumer grouping and everything. Well, thank you very much for listening. And, the questions were awesome. And we'll see you again in a couple of months. Thank you.